Hello, IB learners. Welcome to your first physics introductory lesson. Today we're going to be looking at a very important concept, that is velocity. Velocity is such a simple concept that a lot of students, because they think it's so intuitive, which it is, so they spend little time actually thinking about the deep concept relating velocity. And this caused them a lot of troubles, on the high school physics career, because a lot of concepts that is used later in the physics is deeply related to the concepts about velocity. So when you are having this class, when you are watching this video, please pay attention. Do not think this video is going to be easy, okay? So now let's dive deep into it. So what is velocity? So, the intuitive answer would be, a measurement of how fast things are moving. However, a formal explanation would be an object's movement through space in a given period of time, and that given period of time is often 1 second, because that's the most intuitive amount of time. 3 meters per second means an object has just moved 3 meters in 1 second. 4 meters per second is just 4 meters 1 second. So this is all the intuitive stuff we know. However, notice the definition: the movement of an object through space in a given period of time. So space, time, and object, these three concepts, we know them because space, just the space all around us, time ticking continuously, object, everyday object. These three concepts, we don't need to define them. However, there is one concept that is called movement, which requires definition because it's not stated clearly. Imagine I have 2 points. I have point A and I have point B. If I move in 1 hour from point A to point B, what will be my movement? Imagine, I drove a car and my actual path looks like this. So is the straight line connecting AB my actual movement, or the actual path that I'm taking, that is my movement? So a lot of scholars, they have debate over this. Thus, physicists says, well, they both make sense. Why not make them both correct? Thus, we have 2 different names for movement. One is called distance, which is this actual path. So distance is very, the intuitive words we use in real life, like how much distance you travel. So it's a measure of the actual distance, the actual real path that you're taking. However, a lot of students get very confused on this newer, physics only concept, that is displacement. So this straight line connecting AB or any dots which an object have traveled in a given period of time, this straight line is the displacement of an object. However, a lot of students will be thinking, oh, okay, displacement, it's just a straight line, so it's actually kind of intuitive. However, there are actually a lot of complex concepts deep relating about displacement, and we'll actually be looking at that right now. Alright, war of the century: displacement versus distance. As we've stated before, distance is the actual path taken by an object between point A and point D, and displacement is the straight line connecting 2 points. However, this is just the magnitude. This length of the connection is just the magnitude of the displacement. In this case, it's 5 meters. You will notice that there is a little arrow here. This is the direction of displacement. A lot of students get confused here, so please pay full attention. What does it mean for a displacement to have a direction? You cannot say, oh, I travel from point A to point B. My displacement is 5 meters. They will get physicists absolutely furious on you. So what you can say is this: alright, I traveled from point A to point B, and my displacement is 5 meters to the right, because you've actually traveled from point A to point B, not the opposite, because if you travel the opposite, you will see to the left, right? Because, that's kind of intuitive to think about, right? And the second thing it means is that when I say I have traveled 5 meters to the right, when I say my displacement is 5 meters to the right, I am simultaneously saying my displacement is -5 meters to the left. What the fuck? That's absurd. But if you think about it, if you move to the right by 5 meters, you kind of move to the left by -5 meters, right? I know it's weird, but that's just how physicists define it, and it's actually kind of intuitive, right? And the third thing it means is that when I say I traveled 5 meters to the right, I want you guys to answer this question. How many meters have I traveled to the north? Well, obviously 0 meters, because north is this direction. And when I travel to the east, it does not travel to the north, right? But when I travel to the east, I travel negative distance to the west. You know, that's kind of intuitive, right? So, when I say my displacement is 5 meters to the right, I'm simultaneously saying my displacement is 0 meters to the north and 0 meters to the south. Alright, so I want you guys to know this. Alright, now let me ask you a question. If my displacement is 5 meters to the right, what is my displacement on the direction x? Well, if you have learned about vector component, which I strongly encourage and demand you to learn because it's essential about understanding displacement. When you are moving 5 meters to the right, you are actually moving, you know, if this is 37 degrees, you're actually moving 4 meters to the x direction, right? Your displacements will be 4 meters to the direction x and 3 meters to the direction which is perpendicular to x. You know, this is knowledge of vector component which you should learn, right? You know, if I traveled 5 meters to the right and this is direction x, what am I essentially doing is taking the vector of my displacement and project it down on the direction x. Alright, so this will be my displacement on the direction x. So that's typically how you do it. So an intuitive explanation is this. After I walked 4 meters on the direction of x, I can now walk to a direction that is not fucking related to the direction of x to, I don't know, whatever meters and get to my destinations, right? So when I walk to a point and I can turn perpendicular to a direction that is not essentially related to my original direction and I can get to the point B, you know, this is the point B. This will be my displacement on the direction x, alright? So it's essentially doing vector component. So this is a little bit confusing. I will say the most confusing part about this whole displacement thing. I want you to pause the video and think about it, okay? Alright, to better help you to understand displacement, let's look at these questions, alright? So between A and B, my distance, which is the actual path I've traveled, is 5 meters, okay? So I actually don't know the shape of my path. It could be any shape. And the question is asking what the following values is impossible for my displacements to be. Alright, you guys can pause and think about this. If you paused it too long or if you cannot figure it out, it means you haven't deeply understand about the concept of displacement. But that's fine. Because if we took a look at this, the answer, let me tell you, is C. Why? Because, you know, after I traveled 5 meters, if I just go back to my original point, I've traveled 5 meters and my displacement is 0. So A is absolutely okay. And B, -1 meters. We just need to give this displacement and direction. Let's say the positive direction is to the right. So -1 meters will be 1 meters to the left, right? So this means point B is -1 meters to the left. So I can just, travel 5 meters and to the left. That will also make sense. So B is also okay. And D is also okay. And it's okay in a strict way. Because if my displacement is 5 meters, whilst my distance being 5 meters, what does it mean? So this means the actual path that I have taken is the straight line. So if point D is true, this means I have traveled from A straight to B. Because if I've traveled on any other path, my distance will be greater than 5 meters because the shortest path connecting two dots is a straight line. That's the fundamental principle we've learned in middle school, right? So that's correct. Now, you guys can see why the displacement cannot be 6 meters. If the displacement is 6 meters, this means, the separation between A and B is 6 meters. How can I just travel 5 meters, no matter my shape to get from A to B, I cannot even travel from a straight line to get from A to B. Just don't talk about other shapes, right? So this is the question. Okay, we're finally going to dive into our core topic today, which is velocity. All right, so as we've defined before, velocity is the movement of an object in the space through a unit period of time, right? And we've defined two types of movement. First is distance, second is displacement. Correspondingly, there should be also two physical quantities describing the fast and slowness of an object. That makes sense, right? Yes, it is. And the two quantities are speed and velocity. All right, so let's study them by looking at their formulas. All right, so speed is equal to distance traveled by an object in the space divided by the time. And that makes sense. That is literally how speed is defined. This is a defined equation. It is 100% correct. And from this equation, we can derive these two equations, which is the distance is equal to the speed times time, which you don't need to memorize it because it's very intuitive. Think about it. How far you travel is just how fast you travel times how long you travel, right? So, that's intuitive. I want to run 2 kilometers and my speed is 1 kilometers per 5 minutes. So correspondingly, I should be running 10 minutes to get to 2 kilometers, right? So that kind of makes sense. And it's also true for T equals S divided by V. So these are the formulas for speed. However, for velocity, they are a little bit different. First of all, velocity equals displacement divided by time. You now see the notation for displacement and distance are different. However, in some textbook, they don't distinguish them. However, you need to distinguish these two physical quantities, okay? And the second formula is a little bit different because it's no longer just equal to velocity times time. We have to add a d naught at the front, and this d naught represents the initial displacement of an object. For example, when I'm starting calculating at t equals 0 seconds, the object has already displaced 1 meters to the right. So the v times t is not going to take account these 1 meters. It's just going to take account all the displacement right after t equals 0 seconds. So by adding these 1 meters, I can get the final displacement of the object. All right, so this you need to be very careful about. However, it's not going to appear in your exam, but this concept of adding the initial displacement will be crucial later. All right, so keep an eye on that. Alright, now you may notice one very important property, which is velocity is very similar to displacement. They both have a magnitude, they both have a direction. This means I can only say that my velocity is 5 meters to the right, or negative 5 meters to the left, or 0 meters to the north, or 4 meters per second to the direction of x, right? I cannot say my velocity is 5 meters per second. That will be totally absurd. And right now, I want to introduce to you a very important tools, which you will see later in your high school career, which is DT graph. This is the displacement against time graph. So this graph, any point on this graph gives us an information, and that information is saying, at t equals 2 seconds, my displacement is 5 meters. Yes, this is the information of the graph that is giving us. And this means I can essentially draw a curve. And this curve will give me the displacement value of an object at every time interval. For example, at t equals 1 second, the displacement will be 2.5 meters. And for any other seconds, I can find the value of displacement on the vertical axis. So that's a very powerful tool, right? And one interesting thing is you'll find that as my displacement changed 2.5 meters, the time only went on for 1 second. So what does this mean? This means I moved 2.5 meters in 1 second. So what's my velocity? It's 2.5 meters per second, right? And essentially what I'm doing is I'm taking the differences of the vertical axis and divided that by the difference of the horizontal axis. So this gives me the slope of this line, right? So the slope of this graph is its velocity. This means the steeper the slope, the larger the velocity, the faster the object is moving, and the lower the slope, the less steep the line, the slower the object is moving, which actually makes sense, because if you move slower, you move a lot less in a large period of time, right? In this line, when time has passed 10 seconds, I've only traveled like 3 meters, where 2 seconds already traveled 5 meters. So this line is clearly a lot faster, right? And another interesting thing you will see is that for some object, the displacement at t equals 0, this is t equals 0, is not equal to 0 meters. This means the object will have a y-intercept, and that y-intercept is the d naught I've mentioned above. So d naught is the initial displacement of the object, which is displacement of the object at time t equals to 0. So we've studied in middle school what is the equation of a straight line. It is y equals kx plus b, right? And in this case, y is just the vertical axis, which is the displacement, will be equal to velocity times x. What is x? X is time. Velocity times time plus b. What is b? Now I want you to think about that. Pause. If you cannot think about what is b, this means you haven't fully understand about what I'm talking about. So go back and watch again. B in this case is the y-intercept, which is the initial displacement. So these two formulas match up, right? So it's actually pretty good. And that's all actually you need to understand about velocity in these approximately 20 minutes. All right. And I will see you in the next lecture where I will be talking about acceleration, which is even more complex than velocity. Alright, see you then. Bye bye.